Now, in this session, we change tack. Now, in the first session of this board, so what, three sessions back, I mentioned that the last session, which is now this one for this board, remember 4 sessions per board, would be on the theme of synthesizing, designing, creating, building finite automata. And that's harder than analyzing. So when you analyze an automaton, you're given it. You're given either a state diagram, state transition diagram, and or a formal definition with a 5-tuple. But actually designing an automaton, that's much more open-ended. Right? That's a creative process. Designing anything, design is always an art, right? Because it involves creativity. You have to be creative, and you give 2 people the same task, and if the task is very complex, it's not trivial. You'll probably get 2 very different solutions. That happens. It's in the nature of things. Okay. So you can't reduce design to a recipe. Now what's like this square, 1 session 2 squares, talks about mostly is tips, hints, suggestions, rules of thumb, bits of advice on how to design, because it's non-trivial. Now I've picked up the text with me because if you go to the end of the chapter, and that's a long chapter. It's about chapter 2. So, but even so, there are questions at the end of the chapter, each chapter, and the page number at the end of the questions is 98. Right? So it's a long chapter. But what's stunning is the number of questions. And there are a few solutions offered as well, which is nice. But the number of questions at the end of chapter 1 on regular languages is 65. Right? I was stunned the first time I saw it. So you will have plenty of opportunity to design, not just analyze, but design automata. Okay, so by the time you've done a lot of these many questions, 65 questions, at the end of chapter 1, you should become pretty proficient, effective at designing automata. All right. So, in terms of useful hints, suggestions, how do you design? How do you go about designing an automaton? Well, the main bit of advice the author gives, and I agreed with it because before I read his stuff, that in the past when I was designing automata to some extent, I was doing intuitively what he suggests that you do, and that suggestion is effectively I'll say it now. You be yourself. Pretend that you are the automaton. Okay, and ask yourself when a particular symbol from your alphabet comes in, what would you do? I mean, if you were the automaton, what would you do? So by personalizing it that way, that helps. So you sort of get involved. It becomes personal. And you start thinking, oh gosh, look, a 5 has come in. So what am I going to do with that? Like that. And it's found in practice to be a very effective way of motivating you to to come up with solutions. So basically the idea is pretend that you yourself are the automaton. Okay. So ask yourself, how would you perform the machine's task? Right. Now we'll start doing an example using this, the person, that's you if you like, as the automaton. So the person is the automaton. Imagine you are the automaton. That approach, that method. And your task is you have to design, create, build, construct, right? An automaton that recognizes a given language. I mean, that's the general statement of the task, right? What is an automaton? It's a recognizer of a specific language. Okay, so that's the task. How do you go about designing, creating an automaton for a specific language? Okay, and the second square we'll start on a concrete example where you're given a specific language, and then you're asked to find the corresponding automaton, and assume this language is regular. In other words, there is an automaton that you can find to recognize that language. Okay, all right. Okay, so imagine you're the automaton. You're given an input string, okay, and you need to determine if that input string is accepted by you, the automaton. Okay. Here's another sort of tip. Both you, as the automaton, and the automaton itself, neither, at any stage, as the automaton is reading the input string, it's the same automaton, but it could have huge numbers of different strings coming in, one after the other. Strings, not just the symbols. So the automaton does not know whether the symbol that's just read is the last or not. Okay, you don't know that, and if you are playing the role of the automaton, you don't know the current string, is that the last? Sorry, the current symbol in your input string, is that the last one or not? You don't know. Okay, so you need to keep that in mind. That's why it's helpful to play this role of being the automaton yourself. So say you're in the an accept state. Just a minute, I heard something ping. Let me just check this memory. Just a minute. Yeah, I think that ping was from my computer. So imagine that the last symbol that you read puts you in an accept state. So if and you don't know yet, but say there's no more input symbols. Well, if the input string that you've read so far belongs to the language, then you need to output accept, right? So keep in mind that both you and the automaton, any automaton, does not know whether the last or the previously read symbol is the last one or not. Doesn't know, right? So you have to design your automaton so that if the previous symbol is the last, then you're in a position to give the correct decision. Accept or reject. Keep that in mind. Also critical point. All right. Now another thing to keep in mind is you need to be conscious of some things you need to remember about some certain bits of information. Certain information is crucial, very important. and you need to memorize that, you need to save it, you need to put that crucial information into your memory. Now, the art of design is deciding what information is crucial. And I'll talk about that on the next square.